So we're having all these discussions about azimuth and altitude and solar geometry and all these angles and stuff, and this, like, you guys are all looking at me going, this isn't a math class, this isn't an astronomy class. Or some of you might say, this isn't an astrology class. No, nobody got that one, never mind. Astrology, the horoscope thing. Yeah, never mind. So why am I bringing up all this stuff? For those of you that read the prompt, why am I bringing up all this stuff?
Because it's relevant to how we position things within the house based off of the sunrise and sunset. If you watch certain light to come in the room at certain times, so you have to understand that.
True. One of the things that you'll find in this document, okay, is that there's going to be an object, a wonderful orb that has to be placed in your building somewhere on a pedestal 3 feet off the ground. And on 3 specific days of the year, the sun has to come through a window and illuminate that orb. Now, where you put that pedestal and the orb or the artwork is up to you. You're the designer, right? But your client is asking you to illuminate, to cut a hole in the wall to make a window so that that orb is lit up at the winter solstice. Then another window will open it up and light it up at the equinox, and another one will have to be cut and open it up at the summer solstice. Now, the only way that you can do that accurately is to understand solar geometry. Okay? Does that make sense? So that's part of why we're going through this thing kind of, in all these pieces. So what I'm going to need you guys to do, okay, is I'm going to need you guys to find me the angle of, I'm going to give you guys a handout, and I'm going to ask you guys I'm going to give you guys a handout and a location, okay? And I'm going to ask you guys to give me the time of sunrise, solar noon, and sunset for the equinoxes, the summer solstice, and the winter solstice. Okay? Does that make sense? So before I go there, let me ask you guys this question. Who knows what latitude and longitude are? Okay, who doesn't? Who has no idea? Who's never heard those words? Never heard longitude and latitude? Everybody's heard of longitude and latitude? Okay. Then, now who doesn't know what they mean, though? So, you know what it means? You know what latitude and longitude are? The reason I'm asking these questions is because I don't want to bore you guys with stuff. So I don't want to cover something if everybody knows what it is. So lines of longitude, okay, let me ask this other question. You've all looked at a globe, right? Has anybody never looked at a globe? I need you guys to answer me right. So has anybody never looked at a globe? Raise your hand. You're looking at one right now, by the way, but that's not what I mean. That's not what I mean. So you just kind of look at it up close and you kind of spin it and you see it's got a bunch of little lines going all directions, right? You guys have seen that? Okay. The ones that are circles going horizontally around the Earth, okay, are called lines of latitude. So anybody ever seen the Corona commercial that says something about change your attitude and change your latitude? No? You guys have or haven't? No? Oh, those are Corona commercials. What their meaning is, hey, head from the United States down south to a lower latitude in Mexico. That's what it means. Seriously. Okay, so the lines of latitude are the horizontal ones that go this direction, right? And they go all the way down. What is the line of latitude that is at the center, halfway between the North Pole and the South Pole called? Anybody know?
Equator.
The equator, right? That's halfway between the two. Anybody ever heard of the Tropic of Cancer? How about the Tropic of Capricorn? Do you guys know what that means? The Tropic of Cancer and the Tropic of Capricorn are the points on Earth where the sun's rays strike the Earth perpendicular to the surface, okay, in the summer and in the winter. Okay? So that line runs, you can see it right here. There's a dashed line that looks different than the other ones. You guys can look at it closely. Right? It's a dashed line. That is the Tropic of Cancer. And if you look down below, you'll probably see the Tropic of Capricorn. Okay? So I mentioned to you guys that at our latitude, the sun in summertime does not go straight overhead, right? Let me ask you all a question. If you are standing in southern Baja, California, at solar noon, is the sun on the summer solstice straight up? It is. You can go to a point in Baja, which is south of us, right, where the sun's rays in summertime at solar noon, the sun is straight overhead. Okay? And the further south you go, the sun will actually be past straight overhead. Okay? Just you gotta start to wrap your head around this whole solar geometry thing. Back to lines of longitude and latitude. So lines of longitude and latitude are like a grid that's been superimposed over the Earth. How many of you have ever heard of a game called Battleship? How many of you have never heard of a game called Battleship? So, my foreign exchange students.
Yeah.
So it's this game where you used to take these battleships and you would put them on this board, and then you would start calling out numbers. A-16, hit, right? And you put a little red pin on the battleship, right? Anyway, whatever. How many of you guys have heard of something called a Cartesian grid? All of you should have heard of that in high school, right? And so Cartesian grid is a flat grid, right, that has an x value and a y value, and it has a origin point that is 0, 0. You guys remember that? And if it's a grid, and I asked you to go to position 0, 0 on this grid, would you guys know where to go? You'd go right here, right? And if I said, okay, go to 6, 3, that's a coordinate, right? You would go, which one comes first, x or y? Oh, so you would go 1, 2, 3, 4, 5, 6, right here. And then you'd go 1, 2, 3. That is point 6, 3. What if I said point 3, 6? Oh, all right. X first. 1, 2, 3, and then 1, 2, 3, 4, 5, 6. That is point 3, 6. Now, that works fine if you're looking at a piece of paper, but what happens when you're on a sphere? Well, on a sphere, right, you have to draw lines of latitude and longitude to create a grid. And with those, you can position yourself anywhere on the face of the planet. Back in the old days, and I'm talking the old days, not quite back to the pterodactyl and velociraptor age, but back to the early days of GPS. Did you know that GPS didn't have a little blue dot and you could see yourself walking on the map? Did you guys know that? Back in the early days of GPS, it would give you 2 numbers. And then you had to go to a paper map and go, and you'd have to figure out where you were on that map based on those 2 numbers. Those 2 numbers are latitude and longitude. Okay? Every spot on Earth has a different latitude and longitude. I'm at a different latitude right now. And if I go over here, I'm at a lower latitude. So now I can have a corona? Yeah. I am, seriously. I'm at a lower latitude here. And it's believe it or not, the numbers are that accurate. They're that accurate to where you could actually tell the difference between one side of this building and the other side of this building. Okay? So in order to establish time of day for sunrise and sunset, since it's different everywhere on Earth every single day, right? You have to know how to find latitude and longitude. So we're going to do a quick little exercise in latitude and longitude using Google Maps or using Google Earth. Okay? Does that sound good? All right. So I'm going to stop this video, and just so that you guys understand, we're going to go into the computer lab for a minute, and I'm going to just get you guys to use Google Earth to understand longitude and latitude. Okay? Now, how many of you are not real clear on longitude and latitude? Please raise your hands. I want to know. So you're not clear on longitude and latitude. Everybody else already knows longitude and latitude, which is not what you guys told me on one of these recordings just a few minutes ago.
Well, it's like you don't know the exact definition, but I know what you're talking about, and I know what the purpose of longitude.
And do you know how to use it, though?
Yes. I mean, it's a location on a map. Everyone has one, right? Like, if...
They're coordinates. But the question I guess I was asking is do you guys know how to use them? Do you guys know how to find a latitude and longitude on Google Earth or Google Maps? Okay, so I guess I'm not getting a feeling for it, so I'm just going to take you guys over there and we'll take a look at it real quick on